Booklet 1D. What does that mean? As in the first question? 1D? No, there isn't a 1D. Um, Booklet 2. But which question? 1D. Is it 1D? Is that what you're saying? 1D, this one. Um, just confirm if that's the question you're after. Um, Okay, I'll come to that one in a second, but I'll do this one. Booklet 2, um, 1D. That's this one here. How does sodium react with cold water and what is formed? So a lot of these are difficult things that you won't necessarily. I'll tell you how you could have known, actually. I'll tell you how you could have known this question. So you see over here, it tells you that potassium plus water makes potassium hydroxide. So given that it told you that sodium was in the same group as potassium, things in the same group in the periodic table basically do the same thing or react in the same way. So if a question says, what does that do? Or what does it make? Then surely if potassium did that, then sodium just does that. It becomes sodium hydroxide. That's the answer to that. So that's one mark as to what is formed. You green. And how does it react? Let me just think. I think it's something about quickly. So it reacts quickly. See, just as potassium reacts violently with cold water, sodium does the same thing. So the answer's kind of there at the top because this thing would do the same thing as sodium because they're in the same group. Um, I will go through all of them and then right, is that it? Is that the only one from booklet two for now? I'll move on to booklet three because I have questions. Booklet three, question two, E and F. Let's have a look. Mm, mm, mm. None of these were easy, by the way. Once again, this is why we do this to make you come and ask. Oh, yeah. 2E and F, that one. The large molecule represented in figure two is, the answer is, and again, you wouldn't have known this because you wouldn't have gone through it in the lesson at least, but over the coming sort of years, you will know this thing. The answer is a polymer. A polymer is basically something that's repeated many times, and this N is telling you that we've got the same thing sort of connected to it. So it kind of is another one of those, and then another one of those, another. So rather than just draw them all, we put an N there just to show that it repeats itself. And a polymer is something that keeps repeating. Um, E and F. Look at 2, 1, E. I'll come back to that. And F. Metals can be stretched into wires because the layers of atoms can slide. Anything that's soft, okay, in life, okay, anything that's soft, that's slightly bendy, it happens because the layer, if you could see, and you can't obviously, if you could see what's going on inside it, you would see these layers of these atoms, and when things are in layers, they can slide over each other. And that's what makes them sort of stretchy and movable and bendy and so. So yes, it's slide for that one. And then you also asked booklet three, question 3B, which is here. Um, right, these elements basically sort of fizz around with water and give off loads of like can be sparks and things for some of them. They're called alkali metals. If you wore safety glasses and used tongs, what else could you do? Um, okay, well, it's quite a lot of things. Um, Maybe stand away from it. Let me see what the mark scheme wants you to do. Um, Keep a safe distance. I think that would be fair enough as well. You could say that if you're going to use a little bit of metal, then make sure you use a small amount. Don't like use a massive chunk of it and put it into the water because then it'll be more dangerous. Um, so keeping a safe distance, I think, is probably the simplest one. Okay, that is all of that one done, right? And then booklet 2 1E. If I've answered what you intended to um, come here to ask, then you can go if I have answered any question that you want. I'm not going to do anything else other than answer your questions. Um, so booklet 2 1E, you also asked for. which is here. Um, Lithium reacts more slowly with cold water than sodium. Say two ways the reaction can be made to go faster. Well, given that it says it reacts more slowly, it mentions cold water. I would have thought that one of the answers to this question is probably heat it up or use warmer water. Generally, in chemistry, if you do something, you make it hotter, you get a faster sort of reaction, just like cooking food. And the other thing would be the other one's quite hard actually to get. The other one is to cut up the lithium into pieces. Another way to speed up a reaction. If I've got a big lump of something and I'm trying to do react it with something, then it will be more slow than if I take the same thing and cut it up into little pieces first. If you cut up into pieces, it reacts faster than it does um, otherwise. Hmm. Anything else? As I say, once if I have done what you intended for me to do for today, then you are welcome to go so that I know at least if anybody else is here. Got more. Booklet 3, question 4B. Okay. Um, Sodium atoms react with chlorine to produce sodium chloride. Describe what happens. Okay. It's important to understand this question because these are the kind of questions that come up in GCSE exams as well as in these homeworks that we're giving you. So what you're supposed to know is that sodium is in group one of the periodic table. Okay. What that number tells you is that sodium has one outer shell electron. So if you could see the atom, it would have like, I think it's two in the first shell, then eight in the next one, and then it has this one left over at the end because it has 11 altogether. The group number tells you, and you have a periodic table usually to check these things. Okay, so you don't have to know that, but I'm telling you. The other thing is chlorine. Chlorine is in group seven. In fact, no, before I go to group seven. Because it has one outer shell electron, the thing that all of these atoms want to do is get what's called a full outer shell. The easiest way for this to get a full outer shell is to get rid of this one electron, because then the shell before it is full. So what it tries to do is it loses that one electron. Okay, that's what it does. It loses one electron to get a full outer shell. Okay. And then the more complicated point is that when an atom loses one electron, electrons are negatively charged. If you lose something that's negative, you become positive because overall you have now got more positive things than negative things. Um, so it becomes what's called an Na plus ion or a sodium plus ion. And I'll come back to that. We do the same thing with chlorine now. We say that chlorine, which is in group 7, has 7 outer shell electrons. That's not it, but if something has 7, then it also wants a full outer shell. The easiest way to do that for something with 7 is to get one more because 8 is the most that it can have. And so what this chlorine does is it gains one electron. And it becomes something called a Cl minus ion. So these ions get formed when something gains or loses electrons. And that's basically the answer, because you could have said electron transfer. Transfer means something gaining, something losing. For the final point, I don't think you need to write this, but these two things join together now. What do you know about positive and negative things? They can attract together. And so you get this attraction between these two, and that's why these two bond together. And we get something called sodium chloride. If you can just get to grips with that explanation, then it never changes with these questions. So over the next couple of years, you will find it easier to understand. Um, right, that's for B two booklet to 2.1 2 something. Um, 2I. Okay, I'll tell you what it is. This type of reaction is, God, it must be precipitation. Let me just see. Yeah, it is. It's a weird one that. The only way you know that is that when you get a solid at the end of a reaction, it's generally called a precipitation reaction. The method used to separate solid lead iodide from the solution. If I've got a solution with some solid pieces in it, then the way I can get the solid pieces out is to filter them out, because then the solid pieces stay here and the liquid goes down. So it's filtration. Is that the answer question you're asking me? Let's do the rest of this. What's going on? A soluble compound which contains lead. So soluble, anything that has nitrate in it would be the answer. All nitrates are soluble. So lead nitrate contains lead and is soluble. Um, Draw a ring around soluble compound which contains iodide ions. Um, Most iodides are soluble, but silver and lead are insoluble. It's a very weird table. It's telling you that silver and lead are insoluble, so we can't do those two. So it has to be that one. The answer for that question. And then I suspect you'll probably need help with this. So I'm going to tell you the answer to this question. This is probably the trickiest question in this booklet. Okay, so normally I just tell people what is going on here. The way you answer this question is you explain what is happening to this thing. This magnesium is losing two electrons and becoming, as you can see here, this thing has become this, which is an Mg2 plus ion. And then you would want to say that each iodine, there's two of them. You see how, I mean, it's very hard to see this, but they have gained an electron each there. That wasn't there before, that little dot, because it was there, but it's gone from the magnesium there. Then becomes this one minus ion, which we write as an I minus ion. And so you've used the word, in fact, I've not used the word atom. The magnesium atom loses two electrons. These are atoms over here. That's before they've changed. And once they've changed, they become ions. Loses two electrons becomes that. Each iodine atom gains an electron. That should be enough. Anything else? Do try and ask me all the questions together if possible. I appreciate it. It seems like you're doing it there and then if you don't do that. Um, Anything else from these? If you do have any more, just write them in. I'll just be back in a second. Right, on the basis that you are not, oh, sorry, there's more. Sorry, let me answer these. 1E, can we say to remove the oxide layer? 1E, let me have a look. Is that in booklet one? Is it? No, booklet two, sorry. I don't understand which one 1E is. Can we say to remove the oxide layer? So are we in booklet two? 1E. They show the mass of sulfur dioxide. Is that the question you're asking me about? Mm. Booklet two. I thought I was in booklet. Oh, no, I'm not in booklet two. I'm so sorry. It's because it doesn't say it up there and I'm really confused. 1E. Um, is this the one that we did? But this one? Can we say to remove the oxide layer? So that's booklet two. 1E. Around 1E? Yeah, 1E. Is this not the one we did? Two ways the reactions we made to go faster. Can we say to remove the oxide layer? No, that doesn't really make sense. I'm not sure which oxide layer you're talking about. The question is just, if you were doing this reaction, how could you make it go faster? You could just make it hotter, and you could cut up the metal that you're reacting into pieces. There's no other way to answer that question. Yes, on lithium. No, no, there isn't an ox. No, there isn't an oxide layer on lithium. So when you say to by removing the oxide, that doesn't quite work because if it had an oxide layer on it, it would not be lithium. It would be lithium oxide, right? We're not reacting lithium oxide. We're reacting lithium. So there isn't an oxide. You can't assume there's an oxide layer because there isn't. So yes, no, that they're the only two answers, I'm afraid, for that one. Given that there's nobody else here yet, and there's no other questions, I'm going to end this shortly. So just tell me if there is anything else you feel you need so that we can do it. Otherwise, I will assume there is no more. 7. This question about group 1 metals, it shows the melting points of group 1 against their atomic number. Describe the trend. Well, the trend is that as the atomic number is increasing, and we look, if you draw a line through these points, doesn't it show that as the atomic number is increasing, the melting point is decreasing? That's what we want to say in words. Um, Determine the atomic number and melting point of cesium. Okay, well, this is reading, I think. So read off here. That looks like the atomic number, which looks to me like between 50 and 60, which is 55. And then the melting point will be whatever this number is. It's hard for me to see this. It's about 30, I think. Then, lithium is group 1. How many electrons does the outer shell contain? Well, there's two ways of knowing that. Firstly, if it's a group 1 metal, the answer's already 1. But if you looked at this 3, that tells you that lithium has got 2 electrons in the first shell, and the third one, it's on its own in the second shell. And so that is that. Right, booklet 3, question 5 will be the last one I will do. Um, Lithium reacts with oxygen to produce lithium oxide. Let's draw one line to the correct description. Anything where there's two things joined together, it's a compound. Um, Oxygen on its own is an element because it's on the periodic table. Balance this equation. I think we will put. Well, that's tricky actually. Because we put this two here, what that does is it doubles the lithiums to four on that side. To balance it, we need four on that side as well. What type of bonding is lithium oxide? It is ionic bonding. And relative formula mass. I think we'll do this again in the next month or so. But to work out the relative formula mass, you just do some adding. There are two lithiums here, which means two lots of this. Think of a lithium as weighing 7 and an oxygen weighing 16. Two of those sevens make 14, and one of those 16s is 16. So you end up with 30 altogether. And that's that. Right. The last one I will do then is booklet 3, question 5. I mean, I'm surprised that you'll know the answer to that one, but anyway. Um, Booklet question 5. The charge on the magnesium ion, right? Let me just tell you how you know. The difference between all of this and all of this is that this had this extra shell around the outside, which had these two electrons on it. And now this doesn't have that. So it has lost two electrons, or two of these crosses, from one diagram to the other. If something loses two electrons, it becomes positively charged, which is sometimes it's awkward to remember this. When something loses it, it's now positive, whereas when something gains, it's because the thing they're losing is negatively charged. So you're losing something that is like, as I explained to some of my younger students on Sunday, um, it's a bit like if you lose your worries, you're overall happier. So this has lost two negative things and it's now positive and happy. Um, Calcium bromide has this formula. What does it tell you about the ions in this compound? I think what you'd say here is what this tells you is that one calcium ion, you write just Ca, joins with, or bonds with, might be better, two bromine ions. That's why these little numbers are there. It basically means that in order for this to work, two of those join with one of those. That's it. Okay. And that's it, is it? Question 5. Right. Okay. That's all I'm going to do. But well done for both of you, or three of you, I'm not sure how many there are here, who have turned up at 9 o'clock in the morning to ask me these questions. That's very good. Um, and that's it. We should be back to normal next Wednesday. There's going to be a slight change to these things from May, but I will be in touch about that. It's just that I have to do some preparation with Year 11 students, so we might not have as many of these from May until they finish. But I will let you know. Right, I'm going to end this there.